Hi, everybody. You might encounter some problems where they ask you to give examples of Venn diagrams, maybe with different shapes. So I thought I'd do a few. The first one we're going to do is do a Venn diagram that has to do with, that shows a relationship between squares and rectangles. Okay, so let's think about it. Now, a rectangle and a square, what's the difference? Well, I think if you remember back in the day, when you learned about shapes, everybody learns that a square, all four sides are the equal lengths, right? And you have to have four right angles. For a rectangle, you have to have four sides, right angles, but they don't all have to be the same length, right? They have to be parallel. Opposite sides have to be parallel to each other. So I think that means is if we do a rectangle, a circle an oval to represent all rectangles, where would the square be in that circle? Would it be overlapped? Would it be within it? Would they be totally separate? Well, I think we agree that all squares are rectangles. So the square circle would be totally encapsulated inside the rectangle circle. If you wanted to draw an example, you could just draw a little square, a little shape that has four equal sides. Whereas a rectangle, you could draw a picture where you don't have four equal sides, right? If they ask for examples of each. So if there's an example of squares, rectangles Venn diagram, how about if they asked about, let's try a different one. What if they asked about rectangles, rhombuses? Okay, I always remember rhombuses I think of diamonds when I think of a rhombus. A rhombus, the definition of a rhombus is it has to be a four-sided figure that has four sides of equal length. You say, well, that sounds like a square, but you don't have to have right angles for a rhombus. So are rectangles rhombuses? Are all rhombuses rectangles? Oh, geez, we got to figure that out. So I think what we'll find is there's an overlap between the rhombuses and the rectangles. And what's in the middle? So can we draw a picture of a rhombus? Let's see. A rhombus is a diamond. It doesn't have to have right angles. So here's an example. It doesn't have right angles. All the sides supposedly are the same size. I'm not very good at drawing. What could be a rectangle that's not a rhombus? Right? Those four sides don't all have the same length. It's definitely not a rhombus. So what is the only rectangle that is a rhombus? What is the only rectangle that's a rhombus? The one that has four equal sides, right? So basically, the square is the only overlap between a rhombus and a rectangle, right? So you got to think through these, and it's good to Google stuff too, because if you Google it, you'll come up with a lot of figures, and it's good to look through those. How about obtuse and acute triangles? Who remembers the definition? Let's see. An obtuse triangle, one angle has to be greater than 90. For acute triangles, all the angles have to be less than 90. Remember the rule too, though. All the interior angles of triangles have to add up to 180, right? So obtuse, one has to be greater than 90. Acute, they all have to be less than 90. How can those overlap? That cannot happen, right? So here's an example where you hear two circles don't overlap at all. These are triangles, right? So can you give me a picture of an obtuse? Well, let's see. I'm going to put in something like this. And let's say that this angle down here is 130. And then this angle is 25. And this angle is 25. So that's an obtuse, right? You have one angle that's greater than 90. How about an example of an acute triangle? How about they're all 60s? If you add up these, 130 plus 25 plus 25, that's 180. 60 plus 60 plus 60 is also 180. So there's an example of a Venn where there's no overlap, there's no encapsulation. They're totally separate entities. Okay. So I hope that helps. And like I said, it's good to Google this stuff too. It helps out to look at pictures. See ya.